we will be discussing these things in detail later. So the basic idea is, the basic focus of this course is these different sorts of machines, right? So you see on the screen now, there are various types of machines, right? So we are not going to discuss each and every type of machine. So basically, the idea of this course is to give you the basics, right? So this is a everyday DC machine. So inside a DC machine, this one here, and so we will be discussing some of these things in under this course module, right? Right. So, and the applications are like mostly the motors are, you would see in the industry and in your day-to-day life as well, would be rotary type. In other words, the motion would be a rotation, right? And so we are not focusing much on the application, so we will be discussing these things later. And yeah, so going back to my presentation again. So the second part of this would be, again, it is under machinery principles, which means the basics you need to understand machines are coming from electromechanical energy conversion. So mostly these things you have already learned under the course electricity and magnetism. So permanent magnets, density of flux density, field and poles. So you know that there are south and north poles. So these things we are just going to have a review. And attractive and repelling forces, intensity, flux intensity, permeability. Maybe I believe you have learned these things under electricity and magnetism. So we are going to have a review on these theories, which are essential to understand the machinery principles. Then we will be discussing more about the energy conversion. So electromechanical conversion, in the sense that how electrical energy is converted to mechanical and mechanical is converted back to electricity. So about the Ampere's law and magnetic circuits, etc. These are there would be substantially a high amount of new concepts and theory under this lecture. So the first two lectures, so you would see here just below the content title, so the number of hours we are willing to spend under each topic. So for the first topic we are going to have 2 hours, again 2 hours, and this one which is going to have some new concepts and theory, so we are going to have like 6 hours, right? So thereafter we are going to discuss about the conservation of energy, so something you are already familiar, but still we are going to extend this to the level of what we call the basic machinery applications, right? So we are going to assume so many things which are not going to be real in the practical world, but to understand a practical situation easily, you would need this knowledge, right? So it's like would be mostly these things would be this conservation of energy application would be the level that we are reaching under at the advanced level mathematics course, in other words physics, advanced level physics, right? So right, so going to the next topic, so we're going to spend 2 hours on basics of electrical machines, like all the previous things are the machinery principles. Now we are going to discuss about the construction, various types, and what is linear, what are the different types of motion, like linear and rotating, and what is the motor action, generator action. These things we are going to discuss a little bit in detail. And then we're going to directly discuss about the basic, or as the very primitive type of machine, the DC machine. and we are going to discuss about how a single loop is going to generate torque and etc. So these theories, I believe, already you have discussed on the electricity and magnetism, but we're going to kind of we are willing to dig deep under this course module, right? So thereafter, there would be, again, this is something you may be already familiar with, transformer theory, and this is again going to be a kind of an AC machine. So we are going to discuss how this is going to be categorized as a machine, and the ideal scenario of a transformer and different types, what is mutual induction, the construction and usage, these things we are going to discuss. And at the end, we're going to discuss about what is a varying magnetic field. So this is something completely new for you guys. That is why it is at the end. But I'm trying to make it as simple as possible. So I'll be trying to make it as simple as possible. So let's see what a rotating magnetic field is and what does vector summation of magnetic fields mean, right? So again, this course is mostly on the theory, so there won't be much practical things to this practical kind of work, because these are going to be the basics of machinery. So most of the things you have to keep in memory, memorize, or else you have to learn a theory and apply it, something like that. So basically, in your degree program, you are not expected to design things, which means we are not kind of hitting the level of theory which is going to be needed to design a machine. So basically what we are doing is to realize the operation of a machine. In other words, how it works. That is the question we are going to answer. And if you want to make a machine, this course is not going to be helpful. So the idea is we are going to lay the basics, right? So maybe after obtaining this degree and with the experience and with higher studies, you will be able to reach that level to design a machine. So if you expect to design a machine from the scratch, so this course is not the is just going to lay the basics. This course is not going to give you the knowledge to design a machine, right? So and 60% of the things, so assessment is going to be a compulsory thing, and the things you learn will be assessed for your own kind of betterment, so that you would get to know at which level you are, right? So how good you are, in other words, right? So the end examination would contribute to 60% of the marks or as the grades, and 40% would be from continuous, and 40%, that 40% would be again divided into mid examination, which is going to contribute for 10%, and laboratory works. So these laboratory works are going to be like basics, so not many hard things. So therefore I'm not going to allocate that much of what we call this mark component for that. So it's again going to be 10%, and I'll be allocating 20% for the assignments. And I'm willing to have one assignment as a group project or a presentation, right? Good group projects in the sense that you have to submit a report on a given topic, right? So I'll be explaining these things later, right? So this is kind of the end of my presentation. And I hope that you all are kind of happy with what you're going to get at the very beginning of this preparation for the industry, or as starting of your own business one day. So you're going to get a lot of things from this course module, because let's think that once you are graduated, you're going to start your own business. So being an electrical and electronic technologist, so which would be hopefully be placed just below just next to the engineer, right? So, and with the experience, one day you would definitely be able to, the path would be there, I believe, that is to become an engineer as well, right? So that is how it is done now. What it is happening is, these NDT and HND graduates, they are working at the level of technical officer, and with the experience of 5 to 7 years, they can easily become what we call is engineers, right? So which means design level, right? So they design systems, and what is going to happen is, you will be placed in between the technical officer and the engineer. So which means you are going to have a considerably higher knowledge and skills and performance than technical officer, and will be placed just next to the engineer. That is the expectation, at least, once you get the IES accreditation and everything. And especially if you perform well in the industry, you and your seniors and all the first few batches, if they can perform well in the industry, and if they can win the heart of the industry, so you will be accepted, right? So now the question is, to win the heart of the industry, there are two ways. Like, you can become an employee, or else you can start your own business. So if you are going to start your own business, there would be motors, there would be pumps, maybe you would be fixing ceiling fans, and maybe troubleshooting motors in the commercial buildings, etc. So you're going to give some service from your own company, or else you are going to replace the motor existing one, and you need to uh, select the best matching motor which is available in the market. So for such things you need this knowledge, so we are laying the basic for that purpose. And even if you become an employee, so if the engineer is going to give you some spec and ask you to fix a motor or something, so you should be able to understand those technical terms and things. And if there are going to be problems, some small problems, you will need the knowledge to tackle them as well. So we are going to lay the basic for that, right? So this is not just to obtain the degree, this is not just to pass this module, this is something beyond. So that, please, you need to understand. And again, the knowledge I am sharing is going to be kind of 10% of what you should acquire. So all the other 90%, you need to dedicate by yourself. You need to work hard and acquire it by yourself, right? So I cannot kind of give you everything with the limited time and resources, right? So that you need to understand that is the kind of the nature of any degree program, right? So thank you very much for that. And you can have like a 5 minutes, maybe 6 minutes. Let's okay, have 9 minutes break, right?